Let's take a look at problem 51. We've got square root of 12 x to the fifth y to the seventh over the square root of 3 x to the third y to the eighth. Y to the eighth. Now I don't really I don't like this type of problem typically, so it goes against usually what I tell people to do. Usually I tell people to simplify the radical before you do anything. But sometimes you just spot where they, if you were to put them into a single radical, they would simplify really nice. See, I like 12 divided by 3, that's 4. X to the fifth over x to the third, y to the seventh over y to the eighth. So what we're actually going to do here is violate my rule of always simplifying your radical. So we got 12x to the fifth, y to the seventh, over 3x to the third, y to the eighth. And put them under a single radical. And then we'll simplify this. Well, if I look at the first part, 12 and 3, they're both divisible by 3. 12 divided by 3 is 4, and 3 divided by 3 is 1. Now remember, if you have x to a power over x to a power, then you subtract a smaller exponent from a larger one. 5 minus 3 gives me 2, and you have x to that power where a larger exponent was. So we put x squared up on top. Now let me say that again. If you have x to a power over x to a power, you subtract a smaller exponent from a larger one. 5 minus 3 is 2, and we have x to the second power where a larger exponent was, which was on top. Now here we have y to a power over y to a power. Again, I subtract a smaller exponent from a larger one. 8 minus 7 is 1, and we're going to have y the first where our larger exponent was, which was downstairs. Okay, so now that we've simplified that, there's no more simplifying. Let's split it back apart. It's just like, well, make up your mind. So I'll put it up there, and I'll do this. Those ones disappear. Now, I'm going to simplify this square root before I go on. Because up on top, 4 times 4 is, or 4 is 2 times 2. Maybe I better go to bed. And I'm going to go ahead, instead of using the shortcut, I'll just go ahead and put x times x there. Well, remember the square root, we're looking for a pair of something. Here's a pair of 2's, and here's a pair of x's. So it comes out as a single 2 and a single x. And there's nothing left inside the square root, so it disappears. And we got this. Now as I look at my answers, none of them have square or absolute values in them. So we're not concerned about making sure it's positive. It's an assumption that it is. We can't have, there's two things you can't have. You can't have a fraction inside of a square root, or wait a minute, you can't have a fraction inside of a radical, and you can't have a radical down denominator, so we can't have this one. To get rid of that, we're going to multiply the top and bottom by the square root of y, because when we do that, on top that just becomes 2x square root of y, and down below, if I put those into a single square root, because we're multiplying them together, you end up with y times y. And remember, we're looking for a pair of something. So here's a pair of y's. So those are going to come out in front. And we're going to end up with 2x square root of y over y. Which matches D as in David. So 51D. 51D checks.